Hey, is spanning tree on your mind? Well, what about rapid spanning tree protocol? Find out how to configure and verify next, right here on IT Pro TV.
You're watching IT Pro TV.
That's right, we are diving into the realm of some spanning tree protocol, one of the topics that actually does get insanely confusing at the CCNA level. And here, of course, to help us to configure rapid spanning tree, Anthony Sequeira. Anthony, let's talk about this idea of rapid spanning tree. So it seems like it's fairly simple. Spanning tree, rapid spanning tree, not a lot of difference except one's faster. Is that the end?
Well, first of all, it really is amazing how much faster it is.
Right.
It is, just light years faster. The other interesting thing about it is it was invented by Elmer Fudd. Except
Fudd.
He said WAPID spanning tree protocol.
Oh, my side. I'm.
That's actually a mnemonic device, believe it or not. So when this first came out, it was 802.1W. And I always remembered that it was WAPID spanning tree 802.1W. See the
That
timing
is
there?
that's a great mnemonic.
Yeah.
It really is.
So let's dive right in. So Ronnie mentions classic spanning tree protocol. And if you haven't played with that, if you haven't thought about that for a while, I want you to go back to Ronnie's CCNA and I want you to run through those great fundamentals that Ronnie built for you on classic spanning tree protocol. Now, as we jump into the command line here, you're going to notice that I've set up this topology for us today. It's got plenty of redundancy, right? Which is typical. And that's why spanning tree protocol becomes so incredibly important. We have all of this redundancy, and when we add these redundant links, we could have loops. So spanning tree protocol is going to get in there for us behind the scenes and dynamically block traffic so that we don't have a loop condition. You'll notice in this topology that we've got set up that there's two links between switch 1 and switch 2. Now, to take care of any spanning tree issues we might have there, we have done an ether channel bundle. So that's treated like one link. But still, even with that, we see where there could be loops in this topology. Switch 1 could forward a broadcast, for instance, to switch 4, which could forward it on to switch 2, which would forward it over to switch 1. And there is our loop condition, and the network comes to its knees. Rapid spanning tree protocol is a dramatic enhancement over the previous version of classic spanning tree protocol. But I just want to set this up in this episode too. Realize that even though Rstp is measurably faster, better in almost every way than its predecessor, it's not even something that's sought after anymore. We are designing networks that don't use any flavor of spanning tree protocol. So that's pretty exciting.
That's actually not the first time I've heard that, but actually when we start thinking about it, why are we still learning about it then, Anthony?
Yeah, well, just like anything else, there's going to be networks that are holding on to it for a very long time. And rapid spanning tree protocol would definitely be where they would want to go. In fact, one of the things I want to make clear to you is that many of your Cisco devices now are shipping with rapid spanning tree by default. So you don't even see classic spanning tree anymore. What I set up for us here, Ronnie, is an environment that's the viral default, Cisco's viral tool. If we go into their switch and we do a show spanning tree for any one of our VLANs, we'll just pick on VLAN 1 because we know it's going to be there. We first need to see what version of spanning tree that we are running, Ronnie, and this looks
standard,
classic to me.
It does.
So don't be confused by that. When you see IEEE as your spanning tree protocol, that means it's 802.1D or classic spanning tree. Another clue that we're running classic spanning tree, well, honestly, that's really it.
Yeah.
I can't think of anything else that we could see there that would clue us in to rapid spanning tree. So how do we configure RSTP and verify it? Well, it all begins on one of your devices. Doesn't matter which one you pick, really. What we're going to do is go into global configuration mode, and we're going to say spanning tree protocol mode, and then notice we've got per VLAN spanning tree, which would be how we go to classic. We've got rapid per VLAN spanning tree, what we're going to do. And then in the upcoming episode, we'll do the multiple spanning tree protocol. But so we're going to do rapid PVST, and that's it. What a simple command. Now, if we rerun our show spanning tree command, you can see that we're at Rstp. Great. You can see that, like, as I alluded to before, nothing else has changed. So you really got to look at that field. Although, look at this, we've got blocking on all of these ports. So there is some kind of recalculation, reconvergence going on. It's only going to take seconds here, as you can see. I rerun the command. Now all those ports are in the learning state, and now they're all in the forwarding state. By the way, we're on the root bridge right now. That's why we've got all of our ports in the designated state. They're in the designated role. Thank you, Roddy. And their status or state is forwarding. Okay, now, are we getting any rapid spanning tree protocol advantage right now? The answer is sadly no. And that's because this one switch is doing it for us. That's it in the topology. You see right over here, it is telling us, attention network admin, you may be Rstp, but you are peering with devices that are classic spanning tree. The great news is my topology is working right now. We haven't broken anything, but we're not getting the improved convergence that Rstp gives us. It is not until we go to all of the other devices, and we'll just do one here, spanning tree mode Rstp. There, what did I do wrong? Spanning tree, how about rapid? You got to spell it out. So rapid PVST. I'll end that over on switch 2. Let's go back over on switch 1, and let's rerun the command. And look at this. On these links that were impacted by that change, we are now on a peer-to-peer type. No longer do we see that peer STP. And now we are picking up, at least between those two switches, our enhanced convergence.
Now, Anthony, as we just saw, where it actually does still continue to work, even though one side is classic spanning tree, the other side is rapid spanning tree, the only real disadvantage is that we're not taking advantage of the rapid side of things, but it would still work.
Everything's still going to work. So this allows for you to cut over gradually throughout the infrastructure. But let's face it, you'd want to do this as quickly as possible, no pun intended, because that gives you the great convergence times.
So let me expand that a little bit more. So across our diagram that we had, across the topology that we had, if we only implemented like what we have here, where some links were actually classic, some were rapid, are we still going to go to the slower side of things for performance overall?
Yeah, there will be enhancements between your devices that are truly running rapid spanning tree protocol with each other. But yeah, you're going to have classic spanning tree protocol methods still in use in the topology, and you definitely want to get rid of that.
Okay.
You want to go all Rstp for sure. And here's another interesting point that I want to make in this episode. This is so important. Remember the band-aids that were placed on classic spanning tree protocol. Those were backbone fast, uplink fast, and port fast.
Right.
Did you teach those in CCNA, or those taught?
I did.
Awesome. Thank you, Ronnie, because that's what we did. I'm messing with the director by looking at as many cameras as I can, as quickly as I can. Our production staff here does a great job when we've had too much caffeine. So we've got backbone fast, uplink fast, and port fast. Those are mechanisms, those are band-aids to classic spanning tree protocol to get it to converge faster. The great news, Ronnie, is that uplink fast and backbone fast, that functionality is baked right into RSTP. So those go away. You will not be messing with backbone fast or uplink fast. The big point I want to make is to get the most out of Rapid Spanning Tree Protocol. One thing that you're still going to be doing is port fast. So we have to remember that on devices that connect to our infrastructure that are non-switches, a great example is somebody's workstation or even a server that we've got plugged into our network, those ports are still going to be configured for port fast. So remember that. Uplink fast, gone. Backbone fast, gone. Those commands still exist, but you won't use them in an RSTP environment, but you will be using port fast where appropriate.
Yeah, there's a lot of things that we may not have to do. So I remember like the first time I ended up teaching CCNA, it was kind of like, we're going through all this, you're learning about all this, verification and seeing all this, but you really didn't have to configure it because it came default on Cisco switches.
Yep.
So now this is a part where we really need to pay attention to the extra configuration that we may need. Now, is there anything to the idea of the rapid per VLAN spanning tree? Is that different than what the original standard was?
Yeah, Cisco has always been big on the let's do this per VLAN, and that caught on. And they absolutely do the Rapid Spanning Tree Protocol per VLAN approach. And that does allow you to get clever with the root bridge per VLAN kind of concept. So you can start to do load balancing, utilizing different root bridges for different VLANs. This is a big pain. This is administrative overhead. And this is one of the reasons why we mentioned at the start of this episode that don't get too excited about RSTP. Don't fall too much in love with it, because you may walk into an enterprise where they're like, yeah, we're proud to say there's no spanning tree protocol at all here, because they've just engineered it right out of the equation. How do you get rid of spanning tree protocol in its entirety? Well, you run routed links down to everything, or the big technology that's taking hold is a technology called Fabric Path, where you are using routing intelligence at layer 2, and every single link is going to be up and forwarding. That is, Fabric Path is based on a technology called Trill. That's the open standard, and that stands for like a big something of interconnected links. I totally forget what Trill stands for. It's hilarious though, look it up. And it's just saying, look, all the links are going to be forwarding, and it's ISIS, intermediate system to intermediate system routing protocol intelligence that's actually running in that environment. Now, the good news too is when you move to RSTP, let's jump back at the command line, Ronnie. We don't have to relearn a whole bunch of commands here. Right now, for VLAN 1, we've got this bridge as the root. That's switch 1. How would we change that to switch 2? Well, just like we would in classic spanning tree. So I'm going to come in here and I'm going to say spanning tree. If you're fuzzy on this, just always use context sensitive help. I can say spanning tree VLAN 1, and notice we can set a priority, or we can use what I call kind of the macro command, and I can say root. So I want you to become root and primary. That's right. So this is pretty cool. This is a little macro that says you can we will automatically set for you the priority on this device to make sure it wins the root bridge election. You could go to another device and set it as secondary root, and it'll adjust the priority so it would take over if something happened to this switch. So I just did that command, and notice that's the same exact command that we would use in classic spanning tree protocol. Let's see if it worked. Let's go back over to switch 1. Let's rerun our show spanning tree, and sure enough, we are no longer the root bridge for VLAN 1. Switch 2 took over that job. Notice also, Ronnie, that we can see the new roles starting to pop up in here. So the alternate port is now gigabit 0/0, and that is, remember, a port that's been bookmarked, if you will. If something happens to the root port, which is right here, if something happens to that port, this port will blazingly fast take over that root job. Then there's a backup port. We don't have a backup port on this switch, but a backup port is a fast converging port for the previous, it's backing up the designated port for that link. So you have these fast converging mechanisms inside of Rstp, and that's great. And it's all done for you automatically.
Now, one more question, okay? You've really shown us just one verification command, which is that shows spanning tree. Is there any more that you would, or any more in depth that you would go into than that?
You know, that command gets so much done. There is another one I have used. I'd consider this like a secondary command, and it's show spanning tree summary. So this command gets hugely valuable when you're looking at things like the global default settings. And you got to be careful with some of these. There is some combination of these settings where you can absolutely crash your network. There's a combination you can use of port fast and BPDU guard. I believe it's those two. If configured improperly, you're going to permit a loop. So you got to be very careful with these commands, because used in the wrong combination, you actually create a loop in the network, which is crazy to think about because spanning tree is supposed to be guarding against that. So through misconfiguration, you can wreak havoc.
All right, well, thank you for helping us to understand a little bit more about the idea here of rapid spanning tree. There's a lot of concepts that Anthony did show us in this episode. He actually took us through the configuration of rapid spanning tree as well as how we verify it, and he even showed us how we can switch the root bridge once again to be able to actually on another switch as well. Now, there's a lot more to come. Anthony teased at the idea of multiple spanning tree, but we'll see that in another episode. So this is a great place for us to sign off. For IT Pro TV, I'm your host, Ronnie Wong.
And I'm Anthony Sequeira.
Stay tuned right here for more of your CCNP Encore show.
Thank you for watching IT Pro TV.